Alright, a parabola has a focus of -3, 3 and a directrix of y equals 2. Match each numbered step with the correct step of the process for finding the equation of the parabola using the distance formula. Step 1, let F represent the focus, P represent the point on the parabola, and D represent the corresponding point on the directrix, each with the following coordinates: F at -3, 3, P at xy, and D at x2. Okay, well, the definition of a parabola is pretty much parabola is the set of points where the distance between the focus and any point on the parabola is the same as the distance between the directrix and the same point on the parabola. So with that, what that is basically saying is when you find the equation, when you're finding the equation of a parabola, you want to find the distance of the focus to any point on the parabola, set that equal to the distance, remember it says same as, the distance between the directrix, so the directrix and that same point on the parabola. So we're using the distance formula twice here. First, we're finding it for F to P, the focus to the point, and then again for D to P. So the focus to the point, the focus is located at -3, 3, and the point is represented as xy because it's any point on this parabola. So step 2 is actually first setting these distances equal to each other. And then for DP, again our point D is located at x2 and the point is any point on that parabola. So when we do that, I'm going to actually jump over to a calculator and click distance. And for F to P, again remember F is at -3, 3, so I'm going to use those coordinates. And P is at xy, so I'm going to use those coordinates. And this is just going to show the steps. So here's our distance formula. We're going to plug in our -3 as our x1, our x as our x2, our 3 as our y1, and our y as our y2. So that's where they came up with this x minus -3 being squared plus y minus 3 being squared. Again, remember that's the distance between F to P. So I'm going to be checking. I'm going to actually just write this down right here. So we had the square root of parentheses x minus -3 being squared plus y minus 3 being squared. That's going to equal the distance for D to P. We're going to do the same thing for D to P using this calculator. D, again, was located at x comma 2. So we have x comma 2, and our P again was x comma y. So when we do that, again, this shows us our equation. And so we are substituting x in for x1 and this 2 in for y1 and this x in for x2 and this y in for y2. And so that's where they end up with this equation. So again, remember that's the distance for dp right there. So dp is actually the square root. That's what I'm looking for. So I'm going to keep that up because that's what's supposed to be on this right-hand column. And I'm just going to scroll up and look for one on the left hand that matches this for the FP. So we have x minus a negative 3 being squared plus y minus 3 being squared equaling, and this right here matches this half right there. So that is the correct step. And again, remember the distance of F to P was found to be that, and the distance of D to P is found to be that, as shown right there. So now moving on to step 4, the easiest way to show you this is to let you know that the inverse operation of a square root is a squared. So you would first square both sides, and that would reduce down that square root and squared. So you would just be left with x minus negative 3 being squared plus y minus 3 being squared, and that's going to equal x minus x being squared plus y minus 2 being squared. So then I'm going to actually come over here. Here's a huge clue. Solve for. Now you can either solve for x or solve for y. This is how you tell. One of these variables will reduce down to 0. And see how we have x minus x? That reduces down to 0. And that means I'm going to be left with an x squared because this x right here, when we distribute this one out, will actually become an x squared. This one reduces down to 0. So I only have one x squared here. Right here. Right here we have this binomial that has a y minus 3 being squared. This will give us a y squared, and this will give us a y squared. So those y squareds will reduce out later, and so we know we're solving for a y. Again, if you take anything just to summarize, x minus x reduces down to 0. That means I'm solving for a y. Comma, and then we would just type in parentheses x minus parentheses negative 3 parentheses, just like it looks, plus parentheses y minus 3 being squared. That's equaling x minus x being squared plus y minus 2 being squared. So again, remember that your actual very first step is to square those square roots so that they reduce out, and then you're left with just what's underneath the radical, and so that's what I typed in. And I knew I was solving for y because this x minus x reduces down to 0. So then I click go, and when I do that, I'm going to follow these steps right here, and I'm just going to talk you through it. So they changed from here to here because a double negative is a positive, and then this x minus x squared reduces down to 0, and here's y. And then this 0 plus y squared reduces down to y minus 2 squared. And then the next step is to expand this very first part, and here's the steps for it. So when we click here, again, we're just working with that left-hand side. So this x plus 3 squared is showing you how to expand it here, and it ends up being x squared plus 6x plus 9. If you want to see the steps right here, it's the perfect square formula. And so our A is x, because that's in the first place, and our B is 3, because that's in the second place. And then this lays it out for you. So that actually comes out to be x squared plus 6x plus 9. And then this y minus 3 squared comes out being y squared minus 6y plus 9. That's actually going to be the very beginning of our step 4. So we're going to, again, remember that this x plus 3 squared plus y minus 3 squared is just being replaced as x squared plus 6x plus 9 and y squared plus minus 6y plus 9. And so that's our very beginning of our first. So x squared plus 6x plus 9. So x squared plus 6x plus 9, and then plus y squared minus 6y plus 9. I'm selecting that as a possible option, and I'm going to verify that this right-hand side is what it simplifies down to. And so that this step, this expansion is shown right here where it equals x squared plus 6x plus 9 plus y squared minus 6y plus 9 right there. And I'm matching again that to the left-hand side. And then we're going to jump to this right-hand side, this y minus 2 squared, to right here where it says to expand it. And it reduces down to y minus 4y plus 4. I mean y squared minus 4y plus 4. And that is what that right-hand side comes out to be. Again, if you want to see the steps, it's the perfect square formula, and it lays it out right there for you on how to expand that. So now, from here to step 5, there's still quite a bit of steps to go through. And I will tell you step 5 actually jumps down to here. So once we have the expanded form right here, they're going to subtract that x squared plus 6x from both sides. And so then we have this actually will be minus x squared minus 6x, and this will be minus x squared minus 6x. That's another way to write it instead of this and that. So x squared minus x squared reduces down to 0. And 6x minus 6x reduces down to 0. And notice on this side there's not an x squared, so we still have this minus x squared. There's not an x term to combine it with, and so that's why it's just tagged onto this end for this minus 6, and everything else comes down. So this y squared comes to here, plus 18 minus 6y equals that y squared minus 4y plus 4, and again it was that minus x squared minus 6x. So then we're going to subtract this 18 from both sides, because 18 minus 18 reduces out to 0. And then positive 4 minus 18 does reduce down to negative 14. And that y squared comes to here, that minus 4y comes to here, that minus 6x goes to there, and we have minus x squared right there. And then that y squared comes down here, and this minus 6y comes down there. And then it says to subtract y squared minus 4y from both sides, and this can be rewritten as just minus y squared plus 4y. And this would be minus y squared plus 4y right there. So that's another way to write it. So you'd have y squared minus y squared, which reduces down to 0. Then you'd have minus 6y plus 4y, which reduces down to 2y. And then you'd have negative x squared minus 6x minus 14. And this y squared minus y squared reduces down to 0. And negative 4y plus 4y reduces down to 0 as well. Now step 5 on ours is positive because they actually added the 6y instead of adding the 4y. So they were just working it from different sides, and that's okay. The only thing to consider with that is if we want to change this to a positive, we would multiply it by a -1, and that would change all of these signs right here. So we would end up with 2y equaling x squared plus 6x plus 14. So we have 2y equaling x squared plus 6x plus 14 for step 5. They're skipping quite a bit of work between these steps. And then step 6 would be to divide both sides by that 2. And so this would be a, if we want to do it here, if we divide it by 2 right there, so then we would divide everything else by 2 as well. So this would be divided by 2, this would be divided by 2, and this would be divided by 2. And this is just represented right here the same way. For our step 6, they do want us to actually reduce this. So this has an implied 1. So this will be 1/2. 6 divided by 2 is 3. 14 divided by 2 is 7. And 2 divided by 2 is 1. So this will end up being 1/2 x squared plus 3x plus 7 equals y. And that's how you would go through this.